In this video, we are going to discuss how to solve practical problems related to sets. So for this purpose, we must know three important formulas. So first formula is number of elements in set A union B, that is equal to number of elements in set A plus number of elements in set B minus number of elements in set A intersection B. Okay, so here we must remember one condition, that if A intersection B is phi, that is a null set. Suppose if it is phi, then number of elements in A intersection B must be equal to 0. In that case, number of elements in A union B is equal to number of elements in set A plus number of elements in set B. Okay, so next one can be obtained from the first one, simplifying it. So what to do here, transfer this term to that side and this one to the other side, then you will get number of elements in A intersection B is equal to number of elements in set A plus number of elements in set B minus number of elements in A union B. Okay, then there is one more formula, that is what, let me tell you the last one, number 3. Okay, that is if here you say number of elements in A union B union C, that's equal to number of elements in set A plus number of elements in set B plus number of elements in set C minus number of elements in A intersection B minus number of elements in B intersection C minus number of elements in A intersection C plus number of elements in A intersection B intersection, sorry, here A intersection B intersection C, that is the last one. Okay, we must know these three formulae. Okay, so now we are going to solve the problems of exercise 1.6 of Ncert textbook of mathematics class 11. Okay, 1.6 of Ncert textbook of mathematics class 11. Okay, so here the first question is, X and Y are two sets such that number of elements in set X is 17 and in Y 23 and in X union Y 38. So we need to find the number of elements in X intersection Y. So in the first question it was given that number of elements in set X is 17 and in Y it is 23 and in X union Y it was 38. So let's find number of elements in X intersection Y. So here this must be equal to number of elements in X plus number of elements in Y minus number of elements in X union Y. Okay, so we have used the identity that I have already shown you, that number of elements in A intersection B is given by number of elements in set A plus number of elements in set B minus number of elements in A union B. So this formula is used here. Okay, so just only it is written in terms of X and Y instead of AB. Okay, so that's all. So now let me clean this part. Okay, so now put the values. Okay, so value of this is 17, put here 17, then it is 23 minus this is 38. Okay, so 17 plus 23, that's gonna be 40 40 minus 38, that's equal to 2. Okay, so that is our answer. Now you see question number 2 is similar to the first one. So if x and y are two sets such that x union y has 18 elements, okay, that means number of elements in x union y is 18 and x has 8 elements, so this must be equal to 8, and y has 15 elements, so number of elements in y is 15, and we need to find number of elements in x intersection y. Okay, so it's very simple, same as question number 1. Okay, that's why I'm not gonna solve this. Okay, so let's move on to the next question, question number 3. Now let me show you how to solve question number 3. So in a group of 400 people, 250 can speak Hindi and 200 can speak English. Okay, how many people can speak Hindi and English both? Okay, so if we consider the set of Hindi speaking people be H and set of English speaking people be suppose E. Okay, set of Hindi speaking people we have considered H. Okay, then you see number of elements in set H, number of elements in set H must be equal to 250. Okay, that must be 250, and number of elements in set E, that must be 200. Okay, so n, sorry, this must be E. Okay, that must be 200. Okay, so let me write here equal to 200, and the group of 400 people, so that must be number of elements in H union E. Okay, that must be equal to 400. As it is not mentioned that is there any people in this group, is there any person in this group who cannot speak Hindi and English both. Okay, so that's why it must be 400. Okay, number of elements in H union E. So now let us solve question number 3. Okay, so let H equal to set of Hindi speaking people and E be the set of English speaking people. Okay, so here number of elements in H, that means Hindi speaking people, is given 250 and 200 can speak English, so here it must be 200, and total member in the group that was given, that must be H union E. Okay, in this set number of elements, that must be 400. Okay, so total 400 members in that group. Okay, so we need to find this number of elements in H intersection E. So intersection, when we find intersection of two sets, we take the common elements of the two sets. So if we take the common elements from these two sets H and E, we will get those persons, we will get those people who can speak both Hindi and English. So let's find it. So now this must be equal to number of elements in set H plus number of elements in set E minus number of elements in A union B. Okay, that's it. So now put the values here. This is 250, then this must be, sorry, not this one, this is 200, and here it is 400. Okay, so 250 plus 200, 400 and 50, 450 minus 400, that's 50. Okay, so therefore, so 50 people can speak both Hindi both Hindi and English. Okay, so that's how we can solve. Next question is question number 4. So here you see, if S and T are two sets such that S has 21 elements, T has 32 elements, and S intersection T, okay, has 11 elements, then how many elements does S union T have? Okay, so it is also very simple, easy question. So let me show you how to solve. So now question number 4. Here, number of elements in set as 21 elements. Here set S has 21 elements. Number of elements in set A 21, and number of elements in set T is 32, and number of elements in intersection of S and T 11. Okay, so we need to find the number of elements in S union T. Okay, so it's very simple. So we know that number of elements in S union T, that's given by number of elements in set S plus number of elements in set T minus number of elements in set S intersection T. Okay, so now let's put those value here in this formula. Okay, then what we will get, 21 plus 32 minus 11. Okay, 32 minus 11, that is 21, and sum of these two is equal to 42. Okay, so that is our answer. So now next question is 5. Question number 5. If X and Y are two sets such that X has 40 elements and X union Y has 60 elements and X intersection Y has 10 elements, then how many elements does Y have? Okay, so here number of elements in X, so that is 40, and number of elements in X union Y, that is 60, and number of elements in X intersection Y is 10. Okay, we need to find number of elements in Y. Okay, so it's very simple. So let me show you how to solve this. Now question number 5. So here number of elements in set X is 40, and number of elements in X union Y is 60, and number of elements in X intersection Y, okay, X intersection Y is 10. Now we need to find number of elements in set Y. Okay, so same formula we are going to use here. Okay, we know that number of elements in X intersection Y is equal to number of elements in X plus number of elements in Y minus number of elements in X union Y. Okay, so as we are going to find number of elements in Y, so let me write, or let me simplify this as number of elements in Y, that's gonna be equal to number of elements in X intersection Y, okay, X intersection Y minus number of elements in X plus number of elements in X union Y. Okay, so now put the given values here, then you will get it is 10 and this is 40, and this one is 60. Okay, this is 60. So 60 minus 40 is 20 plus 10 is 30. So this is the answer. So our next question is, in a group of 70 people, 37 like coffee, 52 like tea. Each person likes at least one of the two drinks. Okay, so let us consider people who likes coffee. Set of the people who likes coffee be suppose C, and who likes tea suppose T. Okay, then number of elements in set C is 37. Okay, because 37 people like coffee, and number of elements in set T who likes tea is 52. Okay, so it's 52. So here you see, okay, in this group of 7 people, each of them like at least one of these two drinks. Okay, at least one of the two drinks. Okay, so there is no any person who don't like both coffee and tea. Okay, so each of them like at least one of these two drinks, so it must be considered that C union T, number of elements in C union T must be 70. Okay, so we need to find how many people likes both. That means we need to find the intersection number of elements in C intersection T. Okay, so now let me solve this. So question number 6, let C be the set of people who likes, okay, set of people who likes coffee, and T be the set of people who likes tea. Okay, so in the question it is given, so here 37 people like coffee, so number of elements in set C must be 37, and 52 likes tea, so number of elements in set T must be 52. Okay, so as it is a group of 70 members, so number of elements in C union T must be 70. So we need to find how many people like both tea and coffee. That means we are going to find number of elements C intersection T. Okay, so that's equal to C intersection T. Number of elements in this set is given by number of elements in set C plus number of elements in set T minus number of elements in C union T. Okay, that's equal to, but so let's put here, this is 37, and here, sorry, 52. Okay, 52. Then C union T is 70, so let's put here 70. That's equal to 89 minus 70, which is equal to 19. So 19 people likes both coffee and tea. Okay, so that's how we can solve this problem. So our next question is 7. In a group of 65 people, 40 likes cricket, 10 likes both cricket and tennis. Okay, so let us consider C be the set who likes cricket. Okay, and T be the set who likes tennis. Okay, okay, Here you see in this question, so it is a group of 65 people, so n C union T must be 65, and number of elements in C who likes cricket 40, okay, is equal to 40, and who number of people who like both tennis and cricket, that must be n of C intersection T, that's equal to here 10, okay, and we need to find how many of them likes tennis, okay, that is number of elements in set T, okay, we need to find this. Now question number 7, let C be the set of people who likes cricket, okay, and T be the set of people who likes tennis, okay. So now in this question, so number of elements in set C is 40 because 40 likes cricket, and number of elements in C intersection T who likes both the game cricket and tennis is 10, and as it was a group of 65 people, so C union T consists 65 elements, okay. Now we are to find how many of them likes tennis, okay. So let's solve it. So we know that C union T, that is number of elements in C union T, is given by number of elements in C plus number of elements in T minus number of elements in C intersection T, okay. So that's gonna be equal to, here you see, let's put the value here first, 65, then here it is 40, then number of elements in set T is not given, that need to be found out, and here what is the value, 65, okay, it's not 65, sorry, 10, put here 10, okay. So 65, that's gonna be minus 40 plus 10 is equal to number of elements in set T, okay. So this is equal to what, 25 plus 35, okay. So we can say 35 people likes tennis, okay. That's how we can solve this. Our last question is question number 8. In a committee, 50 people speak French, 20 speak Spanish, 10 speaks both, okay. So 10 speak both, so we need to find here how many speak at least one of these two languages. So here we can consider F be the set of people who can speak French and people who speak Spanish, so we have considered that set is suppose S, okay. Then in this case, number of elements in set F who can speak French, that is 50, okay, and number of elements in set S who can speak Spanish, okay, is 20, and who can speak both, that is intersection of these two sets, okay, it consists how many elements, 10 can speak both, okay. So we need to find number of elements in the set F union S, okay, that is who can speak at least one language, okay, at least one. So now let me show you how to solve this. Now question number 8, that is the last question. Okay, let F be the set of people who speak French. Okay, and S be the set of people who speak Spanish. Okay, so here as you see 50 people speak Spanish, so number of elements in set F is 50 and number of elements in set S who speak Spanish is 20, and 10 speaks both Spanish and French, so intersection number of elements in F intersection S is 10. Okay, 10 people speak both Spanish and French, and we need to find how many of them can speak at least one language, that is F union S, number of elements in set of S union F or F union S. So it's very simple. That's equal to number of elements in F plus number of elements in set S minus number of elements in F intersection S. So when you find here union, then it must be intersection. Okay, that's the logic here. So now you see, let's put the value. So this is 50, so put here 50, and this is 20, so put here 20, and this one is 10, let's put here 10. 20 minus 10 is 10, so that's equal to 60. Therefore 60 people speak at least one language. Okay, that's how we can solve this.